Hello everyone! Today we are tackling a real FE exam question from fluid mechanics, and it's all about orifices and discharge velocities. So we have 4 different tanks, each with different water heights and nozzle cross-sectional areas. They want us to assign the correct discharge velocity to the appropriate tank. Ooh! Let's jump right in. So we are required to find out the discharge velocity of each tank, the Vx. Now the discharge velocity formula is V is equal to C times root 2GH. If you look at the page number 107 of your FE reference manual, we all know the discharge Q is equal to AV. By ruling out, we know that V is equal to C root 2GH. So you got the formula down. The coefficient C is given in the question as 0.6. G is nothing but the gravitational constant. H is the water head of each given tank. Once you substitute the value of velocity head of each tank and their coefficient into the velocity formula, you will be able to easily find the velocity of each tank VA, VB, VC and VD. Okay, now that we got the formula V is equal to C root 2GH over here, let's substitute the values. The C value is 0.6. So 0.6 times square root of 2GH. G is 32.2 foot per second square and H for tank A is 8 feet. Okay, so the value of 2GH is 515.2. So square root of 515.2 is 22.69. 22.6 times 0.6, that gives you 13.62 foot per second. Now that we got tank A velocity, let's find out the velocity of tank B. So 2GH, 2 times 32.2 times H for tank B, the height is 6 feet. Okay, so times 6. Now root of 2GH, that is 19.65. That multiplied by 0.6 is 11.79 foot per second. That is the velocity of tank B. For tank C, the value of H is 10 feet. Okay, so let's go there. 2 times 32.2 times 10 is equal to 644. Square root of that is 25.37. That is multiplied by 0.6 is equal to 15.22 feet per second. Okay, now velocity of tank D is all that is left. 2 times 32.2 times the value of H is 12 foot. So that gives us this. Square root of that is 27.799 multiplied by 0.6 is equal to 16.679 foot per second. Now that we have all the 4 velocities of all the tanks, it's time to match them with the right velocity. So as I was telling you, these are the 4 velocities. If you take it to the given problem, if we take the results to the given problem, so here is what we got. So tank A is 13.62 foot per second, that is over here. So that is what we did, match. Now tank B is 11.79 foot per second. So tank B is 11.79, there you go. Tank C is 15.23 foot per second, there we go. And tank D is 16.68 foot per second, there you go. Now it's time to match the velocities. So the velocity of tank A is 13.62 foot per second. So that is going to be this over here. Tank B is 11.79 foot per second, there you go. Tank C is 15.23 foot per second, there we go. And tank D is 16.68 foot per second, there we go. So if you notice very carefully, the velocity is directly proportional to the water head. So the least amount of water head is 6 feet. If you notice this, that has the least amount of discharge velocity among all the 4 given velocities. Okay, the highest height is 12 foot and that has the highest amount of discharge velocity, which is 16.68 foot per second. So what I'm trying to tell you is the discharge velocity is directly proportional to the water head in this case, because the velocity formula C times root 2GH is not dependent on the orifice area at all.